Now we will start our second chapter, that is the conducting materials. First we will discuss the introduction of conducting materials. Any material which offer a least resistance to the continuous flow of current when it is subjected to a potential difference. The resistivity of conducting materials lies between a range which have the approximate value of 10 raised to power minus 8 to 10 raised to power minus 6 ohm meters. In general, any electric circuit possesses the following properties: resistance, inductance, capacitance. Now we will first discuss the resistance. The resistance is the property of material by which it opposes the flow of electric current. So the current is the flow of electrons, so resistance is an opposition to the flow of electrons. This opposition occurs because of presence of large number of atoms and molecules in the substance through which the current flows. The resistance is denoted by capital R. Its unit is ohm, and this is the symbol of ohm. Now we will discuss the resistance of conductor. The resistance of a conductor is directly proportional to the length of the conductor. That is, if the length of the conductor increases, then the value of resistance also increases, or vice versa. So R is directly proportional to L. L is the length of the conductor. Second, resistance of the conductor is inversely proportional to area of the cross section of conductor. That is, if the area of cross section increases, then value of resistance decreases, or vice versa. So R is inversely proportional to area. Third, resistance of conductor is dependent upon the nature of conducting material. That is, the value of resistivity of conducting material depends upon the type of material, whether it is made of copper, aluminium, etc. So by combining both the factors 1 and 2, resistance is proportional to L upon A. So to remove the sign of proportionality with a constant rho, R is equal to rho L upon A. L is the length of the conductor in meter. A is the area of cross section of material in m square. Rho is the resistivity or specific resistance of materials in ohm meter. So next topic is the specific resistance or resistivity. The specific resistance of a conductor can be defined as the resistance offered by the 1 meter length of the conductor of the material having an area of cross section of 1 square meter. So rho is equal to R A upon L. Unit of R is ohm into area m square, so m into m. L is the length of conductor, that is m. So m and m both are cancelled with each other, so the units of specific resistance are ohms meter. Now next topic is the factors affecting the resistance. First factor, effect of temperature. The resistance of the material depends upon the temperature changes. This is a graph. On the x-axis we have the temperature, on y-axis we have resistance. As shown in the graph, the value of resistance of the conductor is Ra upon the temperature Ta and Rb on the temperature Tb respectively. So the graph shows that with an increase in temperature, the resistance of the conductor increases and vice versa. Second factor which affect the resistance is alloying. First, we will discuss what is the alloying. Alloying is the process of adding impurities in metals or non-metals in a small proportion. So by adding the impurities on the pure metals, the product obtained is called alloy. By adding some impurities to the metal, its resistivity can be increased. Alloys have the higher resistivity than pure base metals. For example, when the copper is alloyed with the zinc, 60% is the copper plus 40% is zinc. So alloyed material is called brass. By alloying the copper with zinc, its resistivity is increased, that is, conductivity is decreased by the 4 times. But tensile strength of brass is much more than that of copper, which is used for rods, heavy plates, knives, utensils, and electric switches. So the third factor which affects the resistance or resistivity, that is the mechanical strength. When the material is subjected to mechanical stress, its resistivity changes due to mechanical distortion on the crystal structure of metal, which result in an increase in the resistivity of material or a reduction in the conductivity of material.